Alrighty, so we are starting chapter 2, which is all about linear functions. So in order to jump into linear functions, we talk specifically about what on earth a function is in section 2.1. So we are representing relations and functions. So a relation is just a pairing of an input and output values. It can be represented as ordered pairs, in which case you've got your x's and your y's stuck together. You might have a table, you might have a graph, or you might have what's called a mapping diagram, and we'll get to one of those in a little bit. Your domain is the set of all your input values. Those are often your x coordinates. And then your range is the set of all output values. Those are all your dependent variables, aka your y coordinates. So in example 1, we want to consider the relation given by all of those ordered pairs. We are first going to identify the domain and range. Well, we said that our domain is going to be the set of all of our input values, or all of our x coordinates. Our ordered pairs have x coordinates of 3, -6, and 2. For me, when you give the domain and range, you need, number 1, curly brackets around your values. And number 2, you need to write your numbers in order from least to greatest. So we've got 3, -6, and 2. So -6 would come first, next 2, and then 3. Our range has all of our y coordinates. So we've got 2, 0, and -8. So again, curly brackets, and we're going -8, and then 0, and then 2, close curly brackets. Okay, next we want to represent the relation using the mapping diagram and then a graph. Our mapping diagram is kind of strange, but we start with two bubbles, one that has all of our inputs and one that has all of our outputs. Well, good news is we already found the domain and range, so our input bubble has just all of our domain values, and our output bubble has all of our range values, so -8, 0, and 2. And then, the thing about our mapping diagram is we literally use it as a map from each input to each output. So the ordered pair 3, 2 tells us that when we start with 3, we end up at 2. So what we do is we draw an arrow from that input to that output, and you need the arrow piece on the end. Then we've got the ordered pair -6, 0. So we're drawing an arrow from -6 over to 0. And then lastly, we've got 2, -8 from 2 up to -8. And there we are. There's our mapping diagram. When we represent these using a graph, we just plot those three ordered pairs. So when we plot ordered pairs, remember that your x's, so going back up to our ordered pairs, our x's tell us how we move left and right, and our y's tell us how we're moving up/down. So the ordered pair 3, 2, from our origin, we're going to move right 3 and up 2. So then that will place us right here. Then we've got the ordered pair -6, 0. So that means we're moving to the left 6 and up and down 0. So this is actually going to place us on our x-axis just to the left 6. And lastly, we've got 2, -8. So we are moving right to down 8. And so that is going to place us in the fourth quadrant, because remember we label them first quadrant, second, third, and fourth. And so that ordered pair 2, -8, and any ordered pairs with a positive x coordinate and a negative y coordinate will end up in that fourth quadrant. And then next we talk about what a function is. So we talked about relations, and those are just inputs and outputs paired together. But a function specifically is a type of relation where every input has exactly one output. So if any input has more than one output, it is not a function. I will even sometimes remember that if it's a function, so if you have a function, your input values or inputs do not repeat. So if you see an input value more than once, with a different output value, not a function. So in example 2, we have the inputs of 2, 5, -1, and 6. Well, none of those repeat outputs. So if you have an input of 2, you only have one possible output, 3. Your input of 5 also has only one output available. -1, you know what the output is. 6, you know what the output is. Now, our output values repeat. That's fine. We don't care. We only care that our input values are not the ones that are repeating. So since our input values do not repeat, yes, it is a function. But when we notice example B, we've got the inputs of -2 with 2 different outputs. And then we've got the input values of +2 with 2 different outputs. Well, we have 2 separate input values that repeat, so this guy is double, not a function. So not a function, just a relation. And for reasoning, we can say our inputs of both -2 and +2 repeat, which is not okay. And then we've got example C. We've got a whole bunch of ordered pairs, and we would look at our x coordinates. We've got 10, 6, 4, and -4. None of those repeat. Again, we kind of notice that the y coordinate 2 repeats, but we really do not care. Because our x coordinates do not repeat, our inputs do not repeat, yes, it is a function. In order to determine if a graph is a function, we can use what's called the vertical line test. So remember, we represent relations using ordered pairs, tables, graphs, or mapping diagrams. And we talked about, so 2a was a mapping diagram, 2b we had a table, and 2c we had a bunch of ordered pairs. Well, we get to use the trick of the vertical line test when we have a graph for a relation. So a relation is a function if and only if no vertical line intersects the graph of a relation at more than one point. So what we do is we draw a whole bunch of vertical lines, and remember that your vertical lines are ones going up and down. And so we should be able to draw as many vertical lines as we want and not have it cross our graph more than once. So in example 3a, if we start from the right, we've got all these vertical lines, we're doing okay. But then if we draw a vertical line at x equals -3, it hits our graph twice. It hits 2 separate ordered pairs, which means that example 3a is not a function. And for the reasoning, we can say that it fails the vertical line test, or the VLT. So then in example B, is that guy a function? Well, if we draw as many vertical lines as we want, we will never intersect our graph at more than one point, right? When we draw these lines, it hits our graph always exactly once. And so since that's the case, yes, it is a function. We can say it passes the VLT. So this guy is a function. And then next, when we have equations with 2 variables, our independent variable is our input variable, which is usually our x. And then our dependent variable, well, the value of your dependent variable depends on what you chose for your input. That's going to be your output variable, and it's often your y. So an ordered pair xy is a solution of an equation in 2 variables if, when you plug in x and y, you get something that's true. So in order to test whether something is a solution or not, you're just going to plug it in. A linear function can be written in the form y equals mx plus b, where m and b are constants, and then x and y are your independent and dependent variables, respectively. And lastly, we can rewrite any function using what's called function notation by replacing your y with this guy. And we have to read that as f of x. You can't just say fx. It is f of x. Function notation is actually really nice because it tells you your independent variable and it names your function. So f of x means that x is your independent variable, and when you've got a whole bunch of functions, you're talking about, oh, f, this particular function. Sometimes we've got g of x, sometimes we've got k of x, m of x, p of x, whatever. It names your functions different things so you can talk about them simultaneously.